The sun will come out tomorrow. Bet your bottom dollar that tomorrow there'll be sun. Just thinking about tomorrow clears away the cobwebs and the sorrow till there's none.
Perfect, Neil. Thank you very much, man. Nobody's done that one. That's a first for us. Out of almost 300 shows, that's the first one that anyone's expressed. So I do like it
You
that you
know,
brought that up.
I figured that people know Annie, whether they
Yes,
know it or not. Like if you haven't seen the movie, you know the song.
you know the person, you know the song, you know the story. Whether you're in construction or not in construction, you know it. That's just if you got kids, you know
Absolutely.
it. Everybody knows it. Welcome to the show, Neil. Really appreciate you being on the show here. We've got a lot of interesting things to talk about. We're going to talk about something that's one of my favorite subjects, which is building science. That's a huge thing for anybody that's in construction. Whether you're south of the border, north of the border, all over the world, we're constantly talking about building science and how to build better and the reasons behind that. So excited to
Absolutely.
have you, man. So I just want to share out the deets for everybody. Let them all know. So we got Neil. It's Friedberg or Friedberg.
Either or,
No, no, no.
depending
Which
on
one
who
is
you
it, man?
ask, depending on who you ask. If you ask someone from Germany, it's Freidberg. If you ask someone from the U.S., it's Friedberg. So
Okay,
I
so
I have no preference.
we're gonna go Germans. We're gonna go U.S.
I will go U.S.
We'll go U.S. Okay, so basically it's Freidberg. So Neil, from your building science manager, you've been with LP for 2 years, and we're talking with LP Corp basically. So www.lpcorp.com, and his email is neil.freeberg. Or Freiberg. Well, I'm going to keep on messing it up back and forth at lpcorp.com. And on Instagram, it's LP_pros, LP Building Solutions. And that's where you find them. I want to do a quick shout out to the boys at Huracan Renovations there. I'm the tee. That's the tee that I'm wearing today. And so I want to just give them a shout out. They're doing amazing work. They started framing, they started doing small jobs, and then they got into doing big rentals. And now they're doing full scale homes, which is all huge kudos to them. So everybody's staying warm and dry as we go into the winter season. And then that's it, man. So over to you, Neil. Where do you want to begin this conversation?
Oh, wherever you want. I
Why
like the
is
flow. So
okay? So why is it so important that we have to be conscious of building science? Like, are we? I know U.S. and Canada, we're very similar. I personally think we waste a lot. I think we build a little too big, and I think that there's a lot of holes in the home. I think that if there's just a little bit of care and effort put during certain stages of the construction process, we can actually make a home a lot better. Which I know that this is not the fancy stuff. It's not, when you see your utility bills and all of a sudden they're not so high. That's not as gorgeous as the marble or the selects for you choose and the furnishings. I get it. I understand all that. But as a homeowner, you've been in there, you want a comfortable home, and it's really about building a proper comfortable home. So we want to dissect the whole house and just start from I love to do two different projects, Neil. A renovation, so we take an existing, possibly a typical suburban, like a house that was possibly built in the 80s, 70s, 80s, 90s, and then try to talk about what we can do and change there. And then new construction, I would love to tackle both those projects and see where we're forgetting and what we should be paying attention to.
yeah, absolutely. Whatever direction. So let's start with retro.
Retro's great. Let's go with that.
Let's start with retrofit. So in general, to the pretext to both conversations, I just want to set kind of the boundary, right? Um, Building science matters mainly because as we build homes, as we do things, the components in which you use the in your wall, in the home, become more of a system. So yes, you can use OSB sheathing on the outside. Yes, you can use fibrous insulation, spray foam insulation. But when you put those together and they have to work together to keep, the either the cold out or the heat out, depending on where you are in the map, um, it affects the way your building operates, right? So if we have something that allows a lot of air leakage in, things like that, you're going to have issues inside the home, whether it be comfort and the way you use that. But it also affects that wall. It also affects the system, right? So you build, we want to build homes that last forever, right? We look at these houses that have been around for 200 years today. Why, right? They had no building science then. they built to what didn't fail, right? They would build, something would fail, they would change it. Now, I don't know if they had codes back then, right? That's a little bit beyond me. I'm
No,
not
they
that
probably
old.
didn't. But what's your first thought on why these century homes? And I'm very respectful of these homes, right? And whenever we do a demo and we uncover certain sections of a home, like that when we're working on those kinds of homes, I am paying attention. I'm just looking at how things were built and why, and I'm trying to figure out there's a reason behind that, and that's why it lasted. We joke all the time that a brand new house that's built today, it will never reach 100 years, and that's a scary
Yeah.
thought. So it's like, what is your thought? Why did those homes last so long for the way they built them?
So I think that they built them to be passive, like
Yes.
100% passive,
Yes.
right? Regardless of what happened, as long as you did minimal maintenance on the walls as needed, they would be around forever. We've decided that we want to control a little bit more physics. And when we control physics, you either um, reduce the effect or lose, right? So there doesn't seem to be like an intermediate. Either you do a good job or you fail, and we failed a lot. I mean, that's why codes exist. That's
Yes.
why,
Yeah.
right? Remediation exists. There's a bunch of stuff that we do because of results of what we do today. So I just believe they've been designed to be truly passive, right? These 14-inch thick brick walls that held up a structure. We use a single facade now,
Yeah.
right? So it's fragile, it wears, it's not as dense, it's not as heavy, there's less thermal mass. So there, it becomes one of those items that it's not an easy conversation when you look at them compared to us because they built their homes to be passive. We don't.
It's ironic, Neil, that I agree with you. That thick wall that basically came from the foundation where you had a rubble foundation and then you just continue building that way. That thick wall is that whole principle from older castles and retaining whatever heat during the season or whatever cool during the season. And we got rid of it. Now, did we get rid of it primarily because homeowners were asking for more space because they're buying a house that's a footprint of a certain size? And now if we get rid of 6-7 inches of that thick wall and we make it timber framing, then we get an extra 6-7 inches of our room in the front in each corner. Is that where the original source of getting rid of that wall and we were just changing material?
And so, well, I don't know. I truly think it could be a partially more room, but I would also argue that it's partially cheaper, right? To build
Yeah.
a stick brain, like stick versus like a thermal mass wall, right? The amount of effort, the amount of work, the amount of labor. And let's be honest, while we have trades that are very specific to their trade, back then you had one guy who built that whole house.
Very true. Very, very true. Yeah, that's a very good point. Yeah. So we start, okay, so the retro, and you've got these thick walls, and now we're going in there and we have to fur out these walls because
Yeah.
now you have to add insulation, right? But now it's also, we have building code standards on what they're asking us to do for insulation. And then there's a number of products out there. And it's always about trying to figure out what we put on the outside or how we can put stuff on the outside and then what we put on the inside, right?
Yeah. So yes, but let me take you one step
Sure,
back.
sure. Yeah.
When we're looking, like let's say you and me have a project today, right? We're going to tear down the wall, look at the actual structure, stuff like that, and we notice like let's pretend that this retrofit is a old ice house, right? Old ice houses had about 24-inch of brick. That's it, no insulation, nothing else. These old ice houses, what happened to that brick, right? Those years that it was being in operation, it would cause efflorescence due to that moisture draw
Yeah.
from the ice, right?
Yeah.
So when we look at a building, we have to condition the material or fail. So when I look at when I would do and make recommendations to architects about like preparing old buildings for retrofit, I would tell them to, depending on your climate zone, you may have to bring in dehumidifiers, pull that moisture out of that brick because it's been holding it for years, right? So I need to condition my structure before I even start thinking of what I'm going to put on there because I need to know how much moisture is in that wall. Because if I put a vapor barrier on the interior side, I may have caused irreparable damage to that wall because efflorescence can come this way and then cool and then start flaking, right? So I have to make sure that these structures, especially something like a thick brick wall that I'm trying to maintain that is older, to pull that moisture out, right? So
But
then we can start looking at what we do.
and that brick was designed to, I guess, wick in moisture, but it's also designed to actually let that moisture escape. Otherwise, the
Yes.
brick starts to deteriorate. And that's the whole thing. You could almost apply that principle to any building material, that it's designed to get wet, but it's also designed, it has to get dry. So otherwise you have failure at that point. So you're very right. Like that's where you'll start seeing someone who does a poor retro, a poor remodel, and all of a sudden you start to see brick spalding on the outside, and you're wondering, well, why is that happening? We haven't had a harsh winter, we haven't had any extreme weather, but our brick is literally failing. Like the face of it is just coming right off. That's because you're trapping moisture somewhere in the wall assembly, and now the brick can't do what it's supposed to do as a building material. So, I mean, that's why you have to be conscious of how you start retroing, especially the older homes. You have to put a lot more care into the older homes, right?
100%, a lot more care, especially because I'm a big believer of the greenest building is a building already built.
I totally 1000%, Neil. Clients ask me how can we make it the greenest possible. You just keep what you have right now. That's what you keep, and you work with it 100% for
Yeah,
sure. Yeah.
yeah. So I want to make sure that that home lasts for another 100 years at least, right? So once we get past that, as a building scientist, I don't care what the building looks like because you can change that.
Yes.
You can always change surfaces, countertops, fixtures. Those are easily changed. What you can't do is you're not going to decide to retrofit a counter and say, you know what, today I also want to change out my insulation. That doesn't happen.
It doesn't. It never happens. Never
So
happens.
yeah, so depending on where you're building, like in your cold climate, right? Because you're in Canada, correct?
Yeah,
I don't want to
we're in
yeah.
Toronto. We're in Toronto. Well, we get the same
Yeah.
climate as New York and the whole eastern side. We're
Yeah.
pretty
So
much the
yeah.
same.
So
Yeah.
a majority of your moisture comes in from the interior surface during the winter, right? So you produce the moisture in the house. Showers, uh, animals produce probably 3 times as much moisture as we do, even though they don't sweat, right? They just breathe it out
Yeah.
constantly.
Yeah.
Um, so it depends on the use of the building, and then start working around that. So I would condition the walls per the climate, then I start focusing on the use, homes, people, and then focus on insulation, structure, kind of then the shell of the home.
To your animal point, it's really interesting that you brought that up because I used to have 2 dogs and I had them for 15 years. And my rooms, whenever they were sleeping in or whatever, my rooms were a lot more warmer when they were in the room, even though they're sleeping on the floor. The room was warmer. And now that I don't have it, I noticed that it's the same temperature. Everything's the same, but the only difference is there's no pets there and the room is not as warm as it used to be. It's really funny. And
Yeah,
we know that this contributes to building science. Like the actual human element inside of a structure actually contributes to the heat of the structure as well.
absolutely.
Yeah.
And so what you experienced was what we call latent heat, right? Hidden heat,
Yes. Yeah.
um, where it increases the humidity, so it increases you in that little comfort map that we like to reference as building scientists.
Nice. Okay, so now we've got the structure, but we got to figure out how we attack that structure. So what's the best way to build off of that structure and still keep it for another 100 years plus?
Yeah, so right on this structure, in like your climate, what I would do is I would try to find a vapor barrier. I towards the inside, right? So I have a 24-inch brick wall. I want to find a way to keep moisture out, but also prevent it from coming in. So I would look at like a vapor barrier or a moisture barrier that is, ideally intelligent. So like, while they're not our company, I do enjoy the product called Intello. It's a
I'm
smart vapor
I'm
retarder.
very
It
familiar
opens,
with it, right?
closes.
Yeah, exactly. So and,
So I
and,
would
and
put that.
I'm sorry, a lot of people, a lot of tradespeople now are becoming a lot more aware of that particular product. We're so used to poly. We're so used to just a plastic rolled on, stapled on, and that's the product. But that's not a smart product to be using because it doesn't do everything we need it to do.
Exactly.
Yeah.
Yeah. So I would always recommend to wrap that, and like, if we're gonna do tilt-in walls, uh, I'm a big fan of a six-sided configuration. So I'll be very honest. When you're looking at insulation and the way it properly works and how you want it you want to control heat transfer, I immediately start looking at the wall, right? So I want some sort of vapor barrier against the brick, and I'd attach it, with appropriate adhesives, things like that. And then I would looking at my wall, right? So I would tilt it up, but I would put some sort of sheathing there on the inside. Now it could be anything simple from cardboard, like a some sort of uh, T-ply, as like if you're trying to be cost effective. OSB is a great product. Um, or you can even go and just do like a foam, like do an inch of foam on the outside of that stud, and then when you lean it up, you have something to seal right. So then that insulation could be spray foam, it could be cellulose, it could be fiberglass, it could be rock wool, right, or a mineral wool. Um, right? So it gives you that option to say, okay, I've taken care of the structure. I'm giving it that option to breathe in and out as needed. I'm providing some structure for my insulation to sit against to help prevent convection,
Yep.
right? And then I insulate with whatever I want, with whatever thickness I want, whether it be code driven or personal driven, right? You can have a thermally broken wall. You can, there's a bunch of stuff.
Yeah.
And then the inside gypsum, right? And your area would be a vapor barrier, gypsum.
Yeah, it depends. If we're
finish it off.
using spray
Yeah,
foam, then we wouldn't need a vapor barrier because a closed cell spray foam would have its own vapor barrier. But if you're using a Rockwell product or another batch or what have you, then you'd have to put a 6 mil poly at that point. But the whole point is that first step, that's the critical one, and what you do before, right next to the brick itself. Right now, you're leaving a gap, or you parking that wall, that prefab wall, so that has that backing. Whether you choose whatever kind of sheathing material you want to choose, you're leaving a gap, or you're putting it right up against the back of the brick wall.
Oh, I'm leaving a gap.
You're leaving a gap. Yeah, that's what I thought.
And this is why I want a sheathing material behind that wall, so that insulation doesn't interfere, doesn't start making contact on the brick.
Yeah.
Because once again, the second that insulation starts touching that existing brick, you're changing physics.
You're transferring. You're transferring.
Yes.
Yeah, and you don't want to be transferring what the brick is doing and what the insulation is doing.
Yep.
Yeah.
Exactly.
How would you do it, Neil? How would you do it? I know that sometimes when I first started reading about it, when you get into the warmer states or downs, like even warmer climates, it's the reverse, right? You're treating the assembly. So how would that be the reverse if you're applying it to those kinds of warmer climates?
Yeah. So because like let's say Texas or Florida, we use a lot of HVAC systems that cool, right? We have heat pumps, so we're constantly cooling. So our vapor drive is from outside in.
Yeah.
Your vapor drive is inside out.
Yeah.
So when we're driving moisture back in, the HVAC system typically handles it. So when I tell people about HVAC systems in the building science perspective, is we're conditioning the building, people inside are benefiting from. That's it. It's not for our comfort. It's to make sure the walls don't rot.
Yes.
And in the South.
Okay.
So
sorry.
So that vapor drive is coming from inside. We leave it vapor open on purpose, vapor permeable, to come in, and then the system will dry it out naturally.
I love that earlier on you said that you are basing everything that you work on based on a 6-sided structure, right? So I know that when you get into construction and you start learning the basics of certain things, you're taught how to do the foundation a certain way. You're taught how to do the first and second floor a certain way, and then you're taught how to do the attic a certain way. That's not the 6-sided rule. And I totally agree with you. 6-sided trumps all that stuff. We have to start getting rid of that mindset that we work this way basement, we work this way main floor, second floor, and we work this way in the roof. We can't do that. Do you want to talk about how that basement starts? I know here we're like not a lot of people in basement in the warmer climates, the southern states, but here up in the northern side, everybody has basements. So we have that because it's conditioned space and we can use it as very valuable real estate space as well too.
Yeah, tons. So coming from Owens Corning previously, I was able to work everywhere, right? My territory, depending on what the specialty was pretty much everywhere. We had a couple people that we would kind of mesh occasionally, but regardless, not clash mesh. But one of the benefits of doing like a basement is you get to decide how your basement is going to affect your house, right? So in a retrofit, it's a little bit difficult because the cost to remove mounds of earth to properly insulate, drain, and do all the steps on the exterior to protect the structure is costly. It's very costly.
It's a little too expensive to do it at that point.
Yeah.
I guess the most that you could possibly do would be adding some sort of rigid SM foam on the actual floor over the concrete slab, and that could help you. But regarding getting outside, yeah, you're excavating and nobody wants to excavate, and then you're damaging landscape, you're damaging walkways, and the number starts getting, and there's a cost, like it doesn't really make sense at that point, right?
Correct. Yeah. So let's assume that the basement doesn't have any water intrusion or structural issues. From there, we can put foam, right? We can wrap. Once again, if this is an existing building, Intello something to protect that moisture from bulk and air, keeping bulk moisture and air coming through those nicks and crannies. You'd seal it up really well. Put this sheet of Intello or smart vapor retarder or vapor barrier, and then you can start focusing on like adding foam, adding thickness to keep that material in, right? So to keep that heat in. And then from there, one of the biggest benefits I like about having a basement is that your HVAC unit, your furnace, your systems to control your houses are in there, right? And if you include it in the space where it's conditioned, they're going to be much more energy efficient. They're going to be much more, versus Texas where we're like, where do we want to put that thing that keeps our house comfortable and works, in the hottest part of the house in the attic. Right?
I know. So make it work really hard to keep you guys comfortable, which doesn't really make that much sense, right? So they're mostly parked in the attic space, right?
Yeah, we live in the attic as far as like our mechanicals. Yeah.
Wow. And so I mean, I guess the mechanical trades that have to get in there for servicing or like that, it just gets very in the heat of the summer, right? Like July and August months, it's insane to get in there. They're sweating. They're probably losing 10, 15 pounds at that point, just going in there to service call.
Easily, it's that small compartment syndrome too, where you should never work alone when you're doing attic work. I've been in it. I used to censor attics for experiments I would do at Owens Corning. I'm very well versed in hot attics in Texas. You know what I mean?
Neil, I get in and I get out, man. I'm like, I can't stay here. This is too much, man. I'm going to pass out. And then I leave and I go, take care of you. You want some water? You want some water? That's all it is, man. Keep you going. I totally. Where are you? You're down in Texas or you're in Louisiana? No,
I'm in Tennessee.
You're Tennessee. Okay, that's what I thought. Yeah.
I moved from Texas to Tennessee when I was hired by LP.
Nice. Okay, and then I also want you to mention, because I know that LP is, you guys have just gotten into the space, right? Like you guys are just the building science part of it. You just started, or no?
Yeah. So it's kind of why they hired me. So I'm working on developing a different viewpoint for LP. While I can't speak to the 100% of the history, the 50 years of LP's existence. I don't. Talking to people, I think this is the first time that they're starting to realize that, the OSB gets affected by the vapor barrier or the house wrap. The facade can affect it. Furring strips or no furring strips, or depending on who you are, rain screen or no rain screen can affect the way OSB works, regardless of the house wrap. Right. So that's where I'm coming in and working with them and helping them design a better system. Working at looking at all our products, right? Our siding, our OSB, and how they work together versus like our other products, right? Like what happens if fiber cement sits against OSB in the South?
Yeah. So I'm assuming, Neil, and you guys probably have more data on this, is that it's easy to sell these principles and these new ideas and these new products to the industry, but it's harder to sell these same things to the homeowner, the end user. Is that the truth, or no? Or is it the other way around?
I think it's true for both, right? So it's hard and easy and hard and easy.
Got it. Okay. Because you get the industry that's trying to adopt, or they don't want to adopt it?
A combination of both. Codes really drives us down here, right? We don't have your standard of air sealing up in Canada. I mean, 1.6 is a tough number to hit.
Guys are trying to get even lower than that. I mean, what is your standard OBC down there, like your building code?
For air sealing?
Yeah.
So depending on what state you're at, it could be anywhere between 3 to 7 still.
Wow. That's high.
Yeah.
That's
it's
really
so high.
Yeah.
It's so high.
Wow, I don't even. I think everybody here is always trying to get to as close as passive as possible, and we all know passive is like what is it, 0.06 or point is that
Point,
0.6?
point six.
0.6. That's what I
Point
thought.
six.
Yeah. So I mean, it's like that's where everyone's trying to get to. No, so that's interesting. Okay, all right, cool. So now we're anything else in the basement that we got to factor in? I think we've kind of covered everything there in the basement floor.
Yeah. Honestly, air sealing, moisture is probably your biggest enemy there. Water, assuming that it's not an issue or structure's not an issue. Air, and water. Water is what like 95% of litigation in homes. So
Yeah,
if we keep water out, if we keep and water in both forms. When I speak about water, I think about it in bulk, which is like a
vapor.
leak,
Yeah,
or vapor. Yeah.
yeah.
And and if you have enough vapor, you get condensation, which becomes bulk, right? So
One of my favorite things to do is to actually test a structure before we start renovating it. And I love that, I'll get a building science person come into the structure and they'll start doing the smoke test. And I think it's worth the time and the money to actually go around because you can't experience exactly what little holes are in your house. And this smoke test will actually tell you where it is, right? Are there any other tests that you know of that can help, or is that the one go-to test?
that's my go-to test.
Yeah, I love
I'll
that test.
pressurize.
Yeah.
I'll fill it up with theatrical smoke and then pressurize it, and I'll go chase every little stream that I find,
Nice.
both in attic and foundation. I did that for a builder once. We were trying to get down to three. I filled up his house, and we literally found his windows. They have these little hollow ports where water gets on the sill and escapes.
Yeah, yeah.
It was leaking through there somehow
The air was leaking through those weep holes in the window frame?
in the window frame. Yeah.
How? Like, how is that?
It's just they're vinyl windows. I'm not trying to bag on or like
No. But there must have been
production
something.
builders, but
Maybe there was like not enough foam or sealant around the unit itself, and it was kind of getting through the actual extrusion and then going through the weep system.
no. So it sounds like your windows are much better than ours. Ours are
Okay.
very simple track systems. So when you shut it, that little finger gasket that
Yeah.
they have there,
Yeah.
it was going through there and coming out.
Wow, I've never seen that before. Okay, so that's interesting.
Yeah.
But you discovered that based on the smoke test, right?
Yeah.
Yeah.
That's what I mean. Like you find everything. I mean, one time we were the electrical panel. Sorry, not the electrical panel. Uh, when you think of air sealing, and regardless of home, and you insert one of these, what are they called? I'm sorry. It's the name is leaving me. It's basically a control system for where you put your modem and your cables.
Yeah, so you
and,
just basically get a data kind of router or like like that kind of a
Yeah.
system there, a hub or
Yeah,
something.
correct.
Yeah, okay.
And so they purposely have holes everywhere. So one, you can screw things to it, right? So that you can insert clips and screw in. But guess what? All that is
They're just holes.
leakage.
Yeah.
They're just holes,
Yeah.
and they don't seal them, and they don't want to be sealed because if you seal the heat in, you seal the air, the heat stays in. You can short electrical systems. So we had to design around how to seal the bay because we can't seal the box.
See, it's funny that you bring that up because whenever I've had an opportunity to work with the client, whether it's a retro or whether it's a new construction, and you're not bringing the insulation just in yet, but you still have to get the panel up there. You have to get these modems. You have to get these boxes going, and you have to drill these holes through whatever it's concrete or through a wall assembly. I'm already foaming. I'm either using rigid or I'm using cans of spray foam. I'm already sealing all that stuff because I know that's going to be a hole in the future. But I can't bring the proper insulators to come in to start doing the installation because we're not at that point yet. So this is valuable information. Before that, I wanted to ask you about. I totally forgot. I lost it. I can't believe I lost
sorry.
it. No. It was something else I was trying to figure out. But let me do a little bit of history and construction here that I want to share with you. So heating bills in U.S. and Canada. These are 2019 stats, right? So heating accounts for roughly. Oh, I just remember, Neil. Now I remember. Are you guys using the same principle that an average, a typical home, when you calculate all the little pinholes all over the whole structure, it adds up to a hole the size of a basketball? Is that how big we're talking on an average home?
I so in tech and like the US,
Yeah, in the U.S.
it's more
there.
it's more like an open window than anything.
Wow, it's that big. We kind of
Yeah.
attribute it to like a basketball size hole. That's how big
Yeah,
of a
no.
hole you have in your house, right? So can you imagine if you just had that, like a 10-inch hole or an 8-inch hole in your house and air is just going in and out, in and out? That's exactly what's your house. Your house is, the homes breathe, right? We have to understand that the homeowners need to understand that it does breathe. It's in and out. So then those holes add up to a much bigger house. So you guys are a window. Wow, that's a
Yeah.
lot of air. Well, that's how you guys get to that magic number of
I mean,
7.
yeah. I mean, it's you can slap a building together and then it meets 7. You know what I mean? Like
Wow.
there's no real effort in air sealing in some of those places, right? So
So sorry, back to heating. So back in the US and
yeah,
Canada, 2019 stats, heating accounts for roughly 45% of energy bills. It's a lot. The most common home heating fuel is natural gas, as we know, used in about 57% of US homes, 61% of Canadian homes. Propane in 80% of furnaces is most expensive system to heat a home. So we get a lot of rural areas that will be on a propane tank and they get filled up every so often. And then you're basically looking at, for heating a home in pro or natural gas, is about $1,000, $1,095 in US and $1,500 in Canadian dollars. And most to least expensive systems per year. This is US data. Propane is 80% furnace. It works out to be about $3,143. Propane in 92%, sorry, propane in an 80% furnace is 3,143. Propane in a 92% furnace is 2,632. And then you have electric baseboards, which I know that we'll talk about, because electric heating, if your home is built properly, is actually a better option than gas, right? That works out to be about $2,485. Oil is basically 70% of the furnaces out there, 2,100. Oil is about oil, I guess, pump is 80% furnace, is $2,000. Heat pump works out to be about $1,200. Natural gas is $1,200. Heat pump with what's HSPF? I have no idea what that is. What's HSPF? You know that, Neil? I don't know.
I
That's that
don't.
acronym for that. I don't know. I have no idea. That's $1,100. So I mean, everyone. It's like I said at the beginning of the whole show. It's not as fancy as all the tile. It's not as fancy as all the decorating stuff and the furnishings and everything like that. But when you start looking at your heating bills, it's a big deal. You found it?
Yeah, it's heating seasonal performance factor. It's
Ah,
like the inverse of it's like the inverse of SEER, right? Seasonal energy
got it.
efficiency rating. It's for the heating part.
I can only imagine, though, when you're speaking to clients and you're talking about all this data, and you and I and a lot of conscious builders out there that are working in the industry and they want to build better performing homes, they get a glazed look over their eyes. Like they're probably lost because none of this is featured on Pinterest, right? It's not. That's just the truth, right?
It's yeah, I mean, right? The information's out there, and it's just like any other community. Building community is just like a workout community. Is you're gonna get 5 billion opinions about one thing.
Yeah.
And as a homeowner trying to weave through that without any basis of building or knowledge in like physics or how buildings works, how system works, it's daunting.
It
Like
is very much.
it it is scary. Like even from my perspective, and I'm in it daily. I'm reading some articles where I'm like that some of it's like not right. Like and I, of course I didn't write the articles and I'm not gonna sit here and comment or bicker in the comments. Like it's not I don't have time for that. I'm over here going, oh, I don't agree with that. Or some people put out great stuff. And all of a sudden I'm like, oh, that I didn't think about it that way. That's great. Right. So but I come from an experience of construction. I come from an experience with building science.
How many
So it's
homes, Neil, have you been in? Because I get the sense that you don't base your ideas, and when you study something, you're not studying some sort of beautifully packaged presentation seminar that it's got a little model and everything's all, you know what I'm talking about, right? You're actually physically walking into different homes of different styles, different eras, different construction building techniques. You're seeing it that way. So I can only assume that you've been in so many homes to see that experience, right?
yes, if you ask me for a number, I couldn't tell you.
No, it's got to be up there. Yeah, for sure.
Yeah, um, I've been involved and anywhere from being boots on the ground, where yeah, I'm in there, I'm looking, I'm working with someone, to I've done some moisture analysis using like Woofy to say, hey, look, this is the building that you're doing. You know, when I worked for Owens Corning, they would sell in the Middle East, right? So I would run moisture analysis for the Middle East, saying, okay, well, this is my recommendation based on the products that we can get to you also, right? So it's not just the US, I've done other things elsewhere.
Wow.
So it's just one of those things that depending on the need is where I kind of get involved, right? So I can be very high level, being, hey, look, this is my suggestion from a building science perspective. Um, this is my recommendation based on your location, the way you build, what it is, or being there, be like, okay, now let's fill up the house with smoke and air seal. Let's I've done forensic work where someone says, hey, I'm getting moisture in the wall, and I have to open up a wall using a boroscope and poke and see and find a leak source, you know, bad material, right? Bad house wrap, sequencing. I've done it all.
Yeah, it's funny you bring that up because it's so true that it's not about one individual product. It's about a system. Yeah, I know you mentioned it at the very beginning of the show, and I've always been an advocate of the system. So you can have all the right products that are going to be applied to this house, but if they're not installed correctly and they don't all work together, one point stops at one point and then another product stops at another point, and that connection point is not proper, you have failures. Right. So it's
Yeah,
really important
correct.
to understand, sure, use all the right products, but install all the right products, right? You
Yeah.
have to, and that's where the construction, I think, industry has a slight failure towards, because we're not always reading all the instructions on how this should be done. And I think that when you go down this route of building science, you have to spend the time and effort and take courses. You have to be a part of forums. You have to do a course somewhere and then get involved and be a part of group discussions. You have to do all this stuff because it's not so much about reading it in a book or reading it in an article. You have to physically grab that product. You have to physically install it and understand why it needs to be, I don't know, primed, rolled. Like it's amazing to have a contractor now with a tool belt that has a roller on it now, right beside the hammer. This is so extremely valuable that you have to have these new ideas, new tools, new everything. That's where you guys are coming from, right?
Yeah, I mean, one of our products requires a squeegee, right? How intimate you have to be to squeegee tape, right?
Which
So
product
like
is that?
our weather logic tape,
Really? And you guys are squeegeeing on now.
we're squeegeeing it. Yeah, we have to squeegee it. We don't. We're working on a roller approval. I'll be honest. I'm hoping to get the results today to say we have a roller application now. But right now we squeegee.
Squeegee seems a little more work, or I guess a little more, you have to be careful.
It yes, right. So it's a tape. You have to watch for nail pops, stuff like that, debris. Regardless, it things become intimate, right?
Yes.
People like to slap things up and walk
Yes.
away, and that's why I like inspectors. That's why I like third party inspectors. They have nothing to gain except to make sure that that house is as it was designed.
Yeah. Yeah. Time is money at that point, right? But the
Yeah,
thing is,
yeah.
if you somehow, as a contractor, selling a home to a homeowner that is going to be built a certain way, I think you have to push the time is money argument a little lower down the line. You know what I mean? And focus
Well,
on the construction.
so that's a great point, right? So time is money. I always tell people when I would do like QA QC with some builders, I would go inspect some insulation or inspect some products, and I'd be like, hey, look, they did it wrong. They have to come back and fix it, right? Come back and fix it. They're not paying you to come back and fix it.
No, never.
That's money lost.
Yes.
That's time, that's fuel, right? That's something that you could be doing something else. So when people say speed, it needs to be fast, how fast? Fast to where you have to come back and fix it, or fast where if you slow down a little bit, do it right, you don't come back.
You never have to come back. Right.
Yeah.
No, you're a very good point. Very good point. Okay, so now we've left the basement. We're still doing the retro. We're on the main floor. What are we conscious of on the main floor? Is it more of a mechanical and all the terminations? So you've got an exhaust fan terminating out. You've got a dryer, I guess, terminating out. You got those kinds of elements, right?
Yeah. So so one quick question. We're building this in Canada, right? Just
Yeah, I guess you could. Let's
in New York area.
Yeah, let's talk about it's colder climate, so we have a four-season, year-round home is what we're talking about. So yeah, that's. But I still am going to ask you about how it works or what little slightly different is when we're doing it in the warmer climates, because maybe one day Manny will be in the Caribbean somewhere, and I want to be paying attention to that home, right? So okay,
Yeah.
yeah, no,
So one of the things that I look at is not just the terminations, the connections on those terminations to the exterior, right? How am I poking through this 24-inch brick to get air out or air in,
yes,
right? So And then if I'm not going to go that way, if I decide to go up, am I building proper chases? Am I building air sealed chases to make sure that they don't interfere with the way I want the building to work naturally? Um, right, inserting air boundaries. That way, we control that chase properly. Noting that if it's a hot chase, like so exhaust vents, like let's say you have a bathroom. This is one of my biggest gripes about like building. Right, we insulate ducts. We don't insulate exhaust fans. Why? We because if you
We're
think about
told
it,
here we have to insulate 4 feet from the point of drywall. 4 feet. That's our minimum. I always do the whole run right to the final point that it comes out. Always.
yeah. So that's great because most builders will put in that accordion
Yeah,
metal
and it's
right
useless.
to an exhaust.
I know it's useless.
And right, so you took a hot shower, you have heat and moisture in that duct with no insulation in a cold, let's say it's cold during the winter, it's just going to condensate and then rot, and then over time it'll corrode and drip, right? So
Yes.
like insulating is just easy, it's cheap, and it's preventative.
I've got a funny
So
short story just to share with you, Neil, is that I was doing a
sure.
job and I was trying to increase the ceiling height and I was using insulation boxes for the light fixtures. And all of a sudden, we ended up spray foaming on top of it. So it all got a nice little warm blanket around the insulation box and everything was fine. And all of a sudden, we're continuing with the work. We're doing the trim. We're doing all the finishing. And all of a sudden, there's like this a drop of water and then another drop of water. And I'm like, it's coming from one of the light fixtures, right? One of the insulation boxes. And it was just a pigtail hanging from there. And I'm like, that's impossible. I'm like thinking, my first thought is there's a hole in the roof. And I'm like, it's impossible. It can't be. It's a brand new roof. So whatever. I ended up getting up to the attic. I got inside. I realized that there was actually moisture inside the insulation box of where the future pot light was going to be, where a pigtail was hanging. And I'm like, there's water inside there. I'm like, it's impossible. So I get inside the attic and I'm looking around and there literally was a small hole in the spray foam that wasn't sealed. And that hot air coming in from the interior was getting through that small hole into the cold air because we were renovating in the winter months. And that's what was forming condensation inside the actual insulation box. And that was
Yeah,
a
yeah.
quick lesson of me learning hot and cold water. That's what happens,
Yeah.
man. So sorry, I got you off track there. So we're
No,
back
no,
to
no. But it's true. Like that's so like things like that. I want to make sure that the ducts are where they need to be. They're if they're in a chase that's inside the conditioned space, great. If they go outside the conditioned space, how do I seal it? How do I protect it from rot, condensation, temperature differences? Because over time we damage our own buildings because
yes.
we don't maintain them properly.
Yeah. I like the idea
Um,
of the chases. I've been a fan of that. It's always a little challenging when you want to try to get all the top three trades out there, the mechanical plumbers and electricians all working together. I guess not so much the electricians, but the plumbers definitely, because when you're still running vent pipes and drain lines for supply lines for plumbing, I like the idea of building that chase. So then here's a nice little warm, cozy area that just belongs to you guys and it protects the home. I do like that, but it's not always feasible to do that, especially when you go back to homeowner in space, right? But yeah, no, have you come across interesting ways to pull that off somehow, or where you can find little nooks and crannies?
I guess it just depends, right? I worked with a new home builder one time, and he literally designed chases in his trusses for the
Oh, wow.
mechanical.
Nice.
And this guy was very particular, and I he was great. I only worked with him like twice, but even in his intermediate floor between the second and first floor, he would build areas where he designed pipes to go down on purpose, right?
Yeah.
So on a retrofit, mate, you kind of have to play by the ear a little bit. It's kind of like a design build, or build design sometimes, right? So you build it and you're like, okay, that's what we did, so I got to put it on paper, kind
Yeah.
of,
But
because
if
you
you
don't
have
know
the
what to expect.
conversation, it's worth it. It's totally worth it to get all 4 or 5 heads all working together and trying to figure out how can we run this all in one line and create a chase for this product, right? All this stuff.
Yeah,
Yeah.
exactly, exactly. So, um, it's also getting one thing I like to tell people is that the builder himself, right? This, whether design or whatever, is putting together the house. Every trade matters. Every trade, respect each other, obviously, but they all need to communicate. Be like, hey
Yes.
guys, look, this is kind of my path. This is the route I'm going. And then I'm going to air seal my space. If I'm coming through here, I'm going to take care of it, right? Because if it fails, you're not going to call the guy who did a terrible job on it. You're going to call the plumber first, right? Hey, look, it's leaking. Oh, well, I didn't do that, right? So
Yeah.
I like them to own the whole thing because as they build, they affect the building too. So to incorporate them, capping, sealing around their own penetration is going to help prevent blaming the insulators for saying, hey, you didn't hit all the pipes. And he's like, yeah, well, you have 5 million pipes I have to hit or 5 million locations I have to hit. I missed one. I'm sorry. Right. But that adds up.
It
So
does.
this is why I like to incorporate, air sealing with plumbers. I want to incorporate air sealing and water when, through electricians, when they're putting the boxes outside, they just hang out a cable. It's like, no, I want you to flash that properly. Yeah, I want you to own it because you're doing it. You're the one who poked the hole. You're the one who needs to design and understand flashing and looking at that. I understand it's going to take a little bit extra time, but you're guaranteeing a better product and you're relieving stress off of one trade to focus on air sealing when all trades need to focus on air sealing and moisture and all
Yeah.
that other items.
Yeah. It's ironic, Neil, that I guess a lot of trades in the commercial side of the industry, they're used to those chases. They're used to like, you belong here, you belong here, you belong here. Everyone works together. They don't communicate though. Everyone does they have their blinders on and they just do their job. But that hasn't translated yet to custom construction. It hasn't translated to residential construction. I wish it would, because we could take a lot of valuable lessons from that. And I think a lot of that has to do with, I guess, engineers and architects and actual mechanical teams that start setting all that up, saying, here's the floor, here are all the units, here's where the elevators, here's whatever, this is where you guys are chasing. And it should be the same conversation in residential.
Yeah, 100%, because it's going to affect how the home works,
Yes.
right? If all your pipes are inside exterior walls in Canada or in the north, that's not a smart thing.
Yeah.
And showers against an exterior wall in any climate is terrible because when you're bare, you don't want to get cold walls. Like you're taking a shower, hot shower, cold walls. It makes no sense.
And then the moisture transfer and everything like that, and then you're wondering, well, my bathroom is moldy and there's something going on, and it's because your bathroom is not drying. It's wet and it's supposed to get dry. It's not doing that. So there's a bunch of things. So we leave the first floor. I guess those are all the ones that we would tackle. Those are all those protrusions and everything.
Yeah, protrusions, making sure things are duct righted, duct correctly, in the correct location if possible. I understand things cross, things go over, under. Don't smash ducts. Like one thing I always tell people is don't smash ducts.
Oh.
Go under the duct. Don't go over the duct.
I get that the HVAC guys and girls, they're the ones that are like the leaders. They come in, they have the biggest runs. I understand all that stuff, but then you get electrical coming in third, and then they're upset. Then they start moving things, and then plumbers come in and like, I've got a 4-inch pipe. It's not as big as your pipe, but I got to fit it. Like I know, but if we all communicate, guess what? Everyone can have a chase. Everyone can have a highway. They can all have a run. Everyone gets it. I totally understand it. I was going to ask you about when you fireplaces. Have you ever tackled, I know not so much in the South, but I mean here everyone loves fireplaces. Everyone wants to do a wood burning fireplace, but homeowners need to, and I had to educate them over and over that adding a wood burning fireplace on a structure, it now compromises or it affects your heating and cooling system. You have to factor that in, especially if it's really close to a cooked surface, a cooktop, and you've got some massive 48-inch cooktop, and you've got a massive 1200 CFM exhaust fan over that cooktop, and now you've got a fireplace. This is how the invention of elevators came, or not elevators, turnstile doors in high-rise came in.
High-rise.
Right? Yep. So it's basically you're creating a vacuum now in that house, and you literally go ahead, use your fireplace and turn on your exhaust fan and go to open up the front door. You physically, I don't care if you're Arnold, you can't do it because your house it's a vacuum now. It's sealed. So we have to factor that in. And I know that most homeowners want that wood burner over that gas, but even with gas, you still have to factor that in because there's still a hole going outside. That's another hole. Yeah.
So, there's an argument about balance, right? So in my opinion, when you're cooking, can I bring makeup air in, right? So if I turn on that big exhaust, how can I bring up makeup air to make up for it, to prevent a vacuum, right? So to help balance it out. And if you don't think about it, or if you put it on high, but you don't design it for high, right, you're going to create the drafting, or even worse, you're going to have air coming in, bringing in soot, dust, things that you don't want to control, right? Like when I talk about buildings, I as a building scientist, I also think about comfort, right?
Yeah.
Is the person allergic to things like what environment stuff, air, indoor air, dust, all that things affects the homeowner itself and how it operates the building or how they operate the building. So, one of the things that when we're looking at like a big vent and that is makeup air, how long do you run it for, right? So you have all these questions, but when it comes to fireplaces, I personally am not a fan of them at all.
At
I
all?
think at all.
The
So
smell, the crackling? No, nah.
no, and for inside of a house, no. If you want like a little covered area in the back with
Okay.
it,
That's nice there
outside, no
too.
problem.
Yes.
Yeah, yeah. Do it outside. And the only reason why I say that is because any benefit with, if you don't, especially in like, while custom homes have much more, if you don't design it right, you're just literally burning and all that heat escapes anyways. Like 90% of that heat is escaping. You're getting some radiation off the embers and the fire, but a majority of that heat escapes. You're not capturing it. There's not like a trunk that goes down the center of the house over your head to help radiate that heat
No,
down.
no.
Like
It's basically nature's TV. That's all it is. It's just a nice image. I understand that. I totally understand that. Yeah.
yeah, so I don't like them. They're an air leakage. They're hard to air seal. If you do it right, you can hurt it. You know what I mean? Like, so
So for the
they're
homeowners,
good.
as long as you understand that there's a lot of education attached to that. If you really want it, we have to factor in a lot of other dominoes, right? It's really important
Yeah.
that certain things are built a certain way. Yeah.
Well, and not just that. The tighter the house, the better the house you build, the less heat you need to heat it.
Yes.
Right. So I worked with a builder, and the lady was adamant about having a fireplace. And the way they compromised was they would insert a TV that looked like a fireplace, and it would heat up the whole house because they designed it to passive. But she wanted that, and so because of that, it would get too hot. She'd have to open her door during the winter because she would be uncomfortable.
I
Like
believe it.
that's
Yeah. Yeah.
like we they're not. I'm not a fan of them. It's uncontrolled. Yeah.
When it comes to building science, I agree with you. It's not, if you really want it, fine. We'll try to do our best, but basically you're just destroying everything that we're trying to do for the house when you're going to use
Yeah.
this thing, right?
I
No.
mean, they're very pretty, right? You can
Yes.
have great hearth, you can have great, mantles. They're gorgeous.
Yes.
But from a building science perspective,
They're
I
a
don't get
sore
it.
spot. I know. I totally agree with you. I totally understand. All right. So then now we're leaving the main floor. We're getting into the bedrooms now. So let's say we're talking about a 2-story structure. We're in the bedrooms now. What do we have to be conscious of? Obviously, the biggest element, I guess, would be the attic space, right? And then
Yeah.
each
So
of the rooms.
not just that, when we're looking at closing doors, we have to find a way to prevent pressure differences, right? So I want to make sure when I open that door, I don't, cause a vacuum, or, it's hard to open the door because it creates the suction. So I also look at like how jumpers, right? So from a ceiling to ceiling, or maybe under door vents to help relieve pressure is something I always look at there. But then when we go above that, we start looking at like the ceiling, right? So are we sealing can lights? Are we sealing all those locations? You have a top plate, and that top plate is basically anywhere between 600 to on a smaller house to potentially even like 1,200 linear feet of just a crack, right?
Yeah.
Your top plate,
Yeah.
right? So how do you deal with that? Where do you deal with it? Do you deal with it from the top, or do you deal with it before you put up the gypsum, right? Do you want to put a gasket up there, right? So I look at those things. I also look at how bathrooms interact with common walls, right? So like if you have an interior bathroom, if you have to do systems to where I like to tell people to put in that the humidistat sensor switch
Yes. Yeah.
to get that human element away from on and off. Because what happens is if you don't turn it on, that moisture will migrate up and then out into the rooms, potentially hurting the rooms around it, right? So
There's great products now there that actually have built-in sensors that will turn on automatically when they detect a certain amount of of humidity in the air, and that's always great. And then there's also timers now. I don't know if the products have actually gone as far as app enabled, but I guess most people don't bring their phone into the bathroom when they're going to shower. But I mean, it's nice to have it automatically censored and motion activated, so it turns on, and you don't have to think about it.
Yeah. So we talked about passive buildings built in 200 years ago.
Yeah,
This is going to be our solution. Technology will help us become passive.
it's nice to hear
So
that.
that's
Yeah,
yeah. So that way you don't have to think about it. It turns on because it turns on. Obviously, you have to maintain the motor, if it switch stuff like that. Yes, there is some downturn to that, but it removing that human element to turning on and off something, because the human never knows when exactly is like the right
yep,
level.
yep.
If you had something that did know that based on relative humidity, would be great. And then we hit penetrations through ducts outside the insulation.
Are you a fan, Neil, of, I'm assuming most of the South is hot roof assembled, or are they
Yeah,
not? Okay, they are, right? That's what I thought. But I know
yeah.
that's
But by hot roof you mean unvented, right?
yeah, unconditioned attic
Yeah,
space. And then, yeah. So, I mean, but up here, I guess we start getting either we'll put a blanket or blown in or what, or bats, and we put it right on the drywall surface, or we'll actually spray foam and insulate the underside of the roof, roofing sheathing, and do it
yeah,
that way, and then create an unconditioned space in there as well, too.
yeah. So I mean, there's paths to both. They each have their positives, they each have their negatives. I think the people who are sold an unvented attic will only find negative in vented.
Yeah.
I'm a bit more passive. I think there's ways to keep a vented attic, but do things right, like burying ducts is as a new thing in the U.S. States, where we put ducts and then we cover with insulation. Um, I was involved in a couple experiments that I was supporting with that. I'm a big fan of that, where you can still maintain the ventilation in the attic, get moisture out, because we talk about moisture in the sense of bulk coming out in. We also don't, like, especially in the South, we don't talk about moisture coming from out in from
Yeah.
the ceiling. We
No.
don't put a vapor retarder up there in Texas. We don't put a smart vapor barrier or even a paint with permeability past a certain point. Between me and my insulation is just gypsum and paint.
That's it. I know.
That's it.
But that's not the best way to do it.
No, no, I mean, it depends on what you want to do, right? So if I'm really focusing on comfort in here, that system works great. But like in Canada, I know that you guys put a vapor barrier
Yeah.
right at
Yeah.
the gypsum, which once again reduces vapor drive,
Yeah.
right? So
It
you guys
does.
are controlling where the water comes from or where it goes.
That's where I'm more of a hot roof kind of science behind it, where I start putting in the underside of the sheathing, and then you create that space there, which kind of lets it breathe at that point, which is a little bit better. I wanted to ask you, I guess down south there, are you guys transferring, or are you mostly gravity fed mechanicals? So are they going through the roof, or are they going through the wall? And I guess they're power assisted components.
So you're talking about like HVAC systems?
Yeah, just HVAC itself. Like any HVAC
Yeah.
system that you guys have, it's got to exhaust
Yeah. So
somewhere.
we have a majority of the HVAC systems in the South and in the States, and so and it's becoming much more of a heating source now with heat pumps. Is a fan driven heat pump with emergency heat in case
Yeah.
it gets super cold. But what happens is we in the South we like to put them in the ceiling, so we don't put them in the wall. Where a lot of people are moving away from in-wall chases. So you know how they typically just put a duct and a hole,
Yeah.
and a duct goes there,
Yeah.
and they
Yeah.
hope air gets to it.
Yeah.
Now you're actually having to start controlling and designing that duct to that register. So you actually have to put in an in-wall duct now,
Nice.
including exhaust. So it's better for how we want the building to work anyway.
Nice. Okay, so I want to talk a little bit of OBC, which is our building code. But are you familiar with the zones? I guess we have a bunch of zones across the entire country, U.S. and Canada, of climate zones, right? So and that dictates how we build in certain areas of the country. So climate zones help determine heating and insulation needs for buildings within them to increase energy efficiency. That's basically the reason. So we look at what the typical range of, I guess, heating and cooling of all over US and all over Canada. Each climate zone has a required thermal resistance, which is the RSI, right? Value of different parts of the building. Most of Ontario is climate zone 5 or 6. Do you know what your area is?
Yeah. So I'm 4,
You're
but I've
4.
lived in I'm four, but I lived in one and I lived in two and three. So
What's one? Where's one?
the new climate zone map actually includes Texas, South Texas, to be in one, but it was initially like Miami, Hawaii, and like Cuba, that
Okay,
area
so
down there.
extreme
So much
heats. Yeah, so you're just heat zones.
high
Okay, high
humidities. Yeah,
humidity. So basically, some areas are zone 7 and 8, 7B. What's set? What do you know what 7 and 8s are? Or no, actually, right here. So based on Ontario, this is just our area here. Zone 5 would be Mississauga, Oakville, Toronto. Zone 6 would be Ottawa, Burlington, Kingston. Very cold climates, which is northern to us, which is Sudbury, Thunder Bay, and Timmins. That's 7A and 7B. And then 7B is actually Cochrane, White River, and then subarctic climate zones, which would totally be way up there. That's zone 8. So basically, it
yep.
starts from 1 all the way up, and then is 8 the most? Is that's subarctic?
Yeah, eight subarctic. So that
Got it.
includes all the way to the most north you can go.
The place that you might visit once in your lifetime, and that's it. And then come right
Yeah.
back down to 1, get a zone 1. Okay, so from here, I want to like what? How much different? This is a retro that we've been talking about. How much different would you tackle new construction? Would you still be creating a double wall assembly for all your perimeter walls and trading? Like, how would you create your walls in that? Now we're not dealing with a 2 foot wide brick
Yeah,
because
yeah.
you just can't
Yeah,
afford it.
so
Yeah,
new construction, uh, let's say you're excavating for a basement, right? Insulate thick on purpose, and not just the walls, the floor, right? I wanna make sure that my floor, basement or crawl space, because we have crawl spaces
insulate.
here, and even slab
Yes.
on grade,
Yeah.
insulate. One of the biggest issues that code is going to start focusing on in the future as far as heat loss, heat gain, is going to be slab, basement walls, crawl spaces, because
Good.
that is our next big hurdle.
Yeah.
We're basically capped out on insulation in the attic. I mean, we have a little bit more. We're basically capped out on insulation of the wall. We have a little bit more. We don't really address crawl spaces very well. We don't really address slab edge. We don't really address under slab or under basement wall insulation very well. So I think that's going to be the next hurdle and the next focus as we continue down this, route to net zero homes and across the Americas.
Are your inspectors? I know that ours. I don't know how much they are here, but are they catching up to us? Because I find that the industry is ahead of the inspections, like the inspectors, regarding how we build in certain things. There's always been so many times that we'll try something new. They'll come on board and do a regular, like a rough or a mechanical inspection, and all of a sudden they'll come in. They're like, "What is that? What is that?" And I keep thinking, I don't understand why you guys keep on asking us, "What is that?" You guys, are they not doing the same amount of homework that we are doing?
No, right? So just like every trade, understaffed, undereducated. Uh,
Yeah, I know,
um,
but they should be paying attention to it.
I don't disagree, right? So code changes. Some you have early adopters. You have people who toe that that anchor and don't want to change. So you get this hodgepodge of like what they inspect, right? So in the area I live in, uh, the area I lived in Texas, some of the inspectors would inspect in city, but then also in rural. Well, in city, we have different codes than in rural.
Yeah.
So in rural, 2009 was the code standard. So they have to know 2009 still, but then also know the 2015 or 2018 that's coming out. You know what I mean? So like,
But are there not memos coming down the pipe saying, "Listen, like you just said, crawl space and insulation factors have been increasing"? And like, are they not getting those memos and going, "Okay, well, we should be looking for those, or at least discussing
it's
it"?
it's tough, right? Because yes, like the ICC puts out great information constantly, allows you to have free access to most codes, right? So you can at least dabble and look at them. Um, but when it comes to like them knowing and reading, they interpret things differently sometimes,
That's a
right?
good
One
point.
person may read something, another
Yeah.
person may read something without the ICC or organizations out there. There are some that their whole goal is to go out and train the inspectors to know what the new codes are and know how to talk about them. And they do that, but never enough.
Yeah.
Never enough.
Yeah, I agree.
Because codes are constantly changing. I mean, have you ever been through a code change process like where there's a
No,
it's very bureaucratic, and
really.
so if
It's a
you
debate. Is it?
change Sometimes, yeah. In those
Really?
things, I spent an hour and a half where they discussed the structure of a sentence because they were concerned it was going to be read wrong. Like
That's a
that's what
waste of
happened. So
time. How about the objective? Why are we here? How about that? And like,
someone called ordered because it's a big group, and so what happened was right. So you publicize this, you put the facts and the math behind it, right? The code changes happens because of there's a benefit, right? They don't
yes,
change it because there's not. It's not because it's they want to. It's because hey, look, if we do it this way, you can save this much money and energy. Or if you do this, this is safer, right? And here's proof. So once it gets out there, then it goes to public opinion. People can comment. Then you get to vote, yay or nay, based on that. And sometimes you have to adjust based on comments. Like ASTM, it's 100%. It requires everyone to agree before it can pass, right? So there's things out there that have been sitting on tables because people can't come to an agreement for years.
it takes that long, don't you? Is it just a
Oh
matter
yeah,
of?
it's one code change is about a 5 year process, easy.
Oh wow, that's too
Yeah,
long.
so
Yeah,
I don't disagree, but
yeah.
that's why I think states and like governments saying, hey, this is our goal, this is the deadline, strive, right, get to it, helps put pressure on people to get there, and it helps manufacturers understand where we're going in the future, right? I'm involved, and I see where code's going, so I have to make sure that when I come back to the business, I'm saying, hey guys, this is where code's going. We need to be looking at these kind of products. We may have to adjust this product. The product we have X may have to be terminated because it may not no longer meet code. You know what I mean? So like that's also what I'm doing in the background.
I want to, because I agree with you about the try to get as much insulation, start from the bottom. You get a lot of heat loss in the basement. You start building up.
Yeah.
You're using timber at that point. And I've got a lot of cred to give to the framers, I think, in today's generation. Not only they're hanging off a caulking gun off their tool belt now, because now you're putting King Jack studs in your building wall and they're running a bead of caulk, whether that's going to be acoustical caulking or what have you, but they're contributing to the actual building envelope of the home, because there is that gap between studs that are tied to each other, right? The
Yeah.
problem I get is I sometimes see them that they're all in their groove and they're a machine, they get going, and you'll get either a seasoned or a new person framer and start squeezing the caulking gun and leaving gaps. That's the
Yeah.
problem I start getting. Now you basically have not really done the purpose of that. And I think as critical as much you think that that's not a critical point, it's extremely critical. If you're laminating all this lumber together and you're creating the headers and you're creating those studs and you're creating that wall assembly, you got to properly caulk those pieces of timber together, right? Otherwise, you'll start having problems for us later on. And then what's going to happen is before you drywall, before you put you know what exactly, right? You're going to have to seal every single line. And that's just more time. And it goes back to your point. We got to come back and do that, right? So as a
Yeah.
GC, I'm not going to ask the drywall guys to do that. I'm going to ask the framers to come back. And then it's going to be an argument because they're up on some roof building rafters at that point, right? And they don't want to come back. So I would just ask all the framers, just like pump the brakes a little bit, get it down in one first gear and put a nice bead of caulking throughout that whole piece of timber and then laminate the
You,
next one.
you know what? One of my biggest this was advice from someone I heard, so it's not my advice. It's stolen. I don't remember who told it to me. I've been in many
I like
meetings.
stolen advice.
Um, when you're working on trades and you have someone who's green, someone who's new, get the most experienced person who does things right to teach them. Because if they're green and you get the guy who does an okay job, well, you now have cemented okay work for that person to do. Get the
Yes.
guy who shows up, takes his time, and talks and trains this person. Because when you have someone who's green and you train them right forever.
Yeah, that's a very good point. That's a very good point. I like that one. I'm going to keep that one. No, it's
Yeah,
true.
yeah. It's
Yeah.
stolen. It's not mine.
No, so okay, so then what else are you going to do in a new construction application? I guess your wall assemblies, you'd be building chases, you would design them in the floor layout as well. You would come up with all that stuff to begin with, even before we start construction.
Yeah, so I would so first of all, walls, exterior walls. What are they doing? My grading, I'd be looking at grading. Where's it going? Do I need to go thicker? I would look at, if it's my custom house, I would always make sure whatever north facing sides are have more insulation, right? So I would build bigger walls on north facing sides on purpose because that's where a majority of that heat is going to escape from, right? So I can talk about the benefits of continuous installation because we have a product there. Yeah, that's a great option. I'm a big fan of reducing thermal bridging. If footprint isn't an issue and you want to build a double stud, a broken double stud, or a stagger stud, 2x8 on the bottom, 2x4 staggered, there's multitude ways of doing anything, right? So it depends on what your goal is as a builder. Mine, I'm a big fan of 2x8 CI. I'll make it up. I'll have to figure out windows and fenestration later, but that to me is probably the premier wall in a cold climate.
I'm not disagreeing a single word with you, Neil. I totally believe. And is it me and you or anybody in this industry that finds a thicker wall makes for a cozier room? Or am I just taking crazy pills at that point?
It's fact, right?
It feels cozier when you're actually in that room, when you see, and you talk about the window wells, and I agree with you. I'd rather see a larger jam, you know what I mean? And have that, and then also there's a nice conversation to have with the clients. You're going, listen, do you want me to build a little window seat here? So then when it's winter or when it's summer, the kids can sit here, read whatever, laptop, and work here instead of just a normal size windowsill, right? That's why it feels cozier. It totally feels a lot cozier. And you're the first person, I've spoken to so many building science people. You are the first person, because most science people will talk about that north-facing wall and having more insulation in that wall. But their second sentence following that is always, the client will never like that because now the house is becoming a little smaller. You're the first person that basically just said, no, we just make it that wall. We don't even basically, you're not saying it, but that's how I understood it. I wouldn't even tell the client. I go, we made it thicker because we know that this wall is going to get beat up by Mother Nature and we need that extra protection on that wall. And that's a very 100%. Good point. Yeah.
Yeah. Especially if it's, and let's be honest, for whatever reason, we have somehow landed to where north side of the building is where the master is anyways. So it's going to be either the most uncomfortable room for them, or it's like a kid's room, a family, right? So like it gets used. Do it right.
I agree with you.
Why make it an option? So I'm a big fan of, if I'm going to set a standard as building, I'm going to do it across the board, right? So I don't give that homeowner an option. This is how I build. You're hiring me because I build like this.
Yes. Yeah.
So that's it. Like, there's no ifs, ands, or buts. You can let them know that that's what you're doing. Screw the square footage. Comfort, energy is going to make up that square footage in the life of the building.
I agree. I totally agree. I love the 2x8s. I love that whole assembly there. I love that you're putting insulation in between. I totally love that. What else are we doing? What other things are you considering? A lot of taping, making sure everything's properly done. And don't give it to the green guy who doesn't really want to be there and he's on his phone looking at TikTok. Give it to somebody who actually cares about doing this properly. Yeah.
And then, so at the sheathing, right? So OSB, I recommend our Smart Side and our Weather Logic or Nova Core, depending on what path you want to go.
How thick does that come?
Our natural plug.
No. How thick is it?
Yeah. So currently it's 1-inch foam on 7/16 inch OSB.
Okay.
So that's what we're doing currently. And it's OSB out. So you still have to house wrap. It is an extra step. We'll do things later in the future. But right now, that's what we're doing.
You don't have to just tape the joints. You have to still full wrap?
Yeah, so you have to full wrap because there's no WRB on that system.
Got it. Okay. All right. Okay, cool.
But regardless, I'm a big fan. And then on top of that, I would use a gasket that I'm working on around the perimeter. So, you're talking about caulking. That's great. Liquid applied. I like a seal gasket.
Yeah,
if you're modified.
Yep, me too.
Air seal. And I put it around windows, fenestration, right? Corners, sometimes connections. Because, we all have products out there. House Wrap does a great job of field, right? Great job at field. Nobody talks about the interconnection of top and bottom of that wall.
Yeah, I know. That's what I was talking about, the system. I know. I know.
So I'm including that in my design. Walls. After that, I can texture whatever texture I want. I can paint it pink if I want to. I don't care. Color doesn't matter. Texture doesn't matter. The system and the wall matters. So once I figure that out, I'm pretty much golden inside, right? And then one thing I do want to note is that garage wall connections, treat it as an exterior wall, even if it's an attached garage. Treat that connection as an exterior wall. What you did in your wall is what you do in there. Most people go right to a 2x4 or 2x6 with some insulation in the middle, and that's it. No,
it's a lost opportunity. It's a complete loss of opportunity, and it's a fact. Even if you don't insulate a garage in the colder temps, the temperature inside the garage versus the temperature that's outside, there is a dramatic difference. And now, like you just said, and I'm 100% on board with that, you treat that wall assembly the same way. Throw the gasket, throw on the seat, like tape it properly, throw on insulation in there, do all that. You actually are creating, I guess, a cooler. You're making
Yeah.
it warmer at that point. And guess what? When it's colder temps and you're getting into your car and it's parked inside the garage there, your car is going to be dramatically warmer. And then you leave and go outside and deal with Mother Nature. But I agree with you,
Yep.
man. That's so important to do that.
Yeah. The perimeter. I recommend a mechanically controlled exhaust with motion detection. And the reason why I say that is because motion and sound. I apologize. Motion and sound. Because what people do in the winter, they leave the garage door closed, and guess what they do? They turn on their car.
Yeah.
And if you have a leaky house, where's that exhaust go?
Yeah. It's going right inside the house. I know.
Go inside the house.
Dangerous.
So
Yeah.
I'm a big fan of a vent, continuous. Some people like a continuous on vent. I like those too. But when sometimes you don't need it. So I like one that senses sound and motion. So as you're in there, it's pulling out that heat. You know what I mean? So ventilate your garages. Period. No ifs, ands, or buts.
Yeah, no,
Ventilate.
I would you go as far as throwing on? Now this is all new construction. Would you throw on some rigid foam underneath the concrete slab of the garage before you actually pour?
Yeah, 100%.
Yeah.
I like
For the cost
keep it
factor and
warm.
the time attached to it, might as well do that. Yeah.
Yeah, I mean, because you're already doing it under your slab,
Exactly.
just do it. Just add it to it. It doesn't hurt it.
Yeah.
Obviously, design it correctly for structure, weight, stuff like that. Right? No, don't skimp on engineering. Never skimp on engineering because if it fails, it fails.
Yes. Now, we actually didn't talk about any, I guess, mechanically speaking, we could talk a little bit about HRVs and then ERVs and do you guys get involved with those down south? I know here it's building code.
Yeah.
Yeah, everything's
My
there.
house has it.
Okay, perfect.
My house has an ERV.
The biggest problem is trying to get homeowners on board to maintain it. Now, if they don't maintain it, bring somebody in, and we always recommend twice a year, if not more, go seasonally to bring in an HVAC expert to come in to service your units, right? Because you may not want to do it. Like people forget to change their filters. People forget to clean the filters in the HRVs, ERVs, right? So it's like these are critical things, man.
So obviously depending on someone's cost and pocket, right? I'm not trying to spend people's money intentionally. I'm a big fan of people working like you, a builder, saying, "Hey, HVAC guy, do you have a service that you provide?"
A plan, yeah.
Yeah, let me include it for the first year of the house. Let them get comfortable. You come in once every 2 months to change filters, check on systems, and that's it, right? It's a flat rate, and then extend that to them. Say, hey, this is what it would cost. Let's say it costs $400 a year, right? $400 a year to maintain a system and not fail. You'll pay for it. It'll pay for itself.
Yes,
because that system will now last longer than that 7 years that a coil will fail, or you know what I mean? Like you're someone's looking at it. That person going up there checking on it will see if there's water in that tray and if it's dripping right? So all of a sudden things start taken care of. And you're not one day your ceiling falls on you because it's been overflowing because it's been clogged, right? So
it's funny, Neil, that most homeowners will ask the HVAC team, how long will this furnace last? How long will this AC unit last? How long will all these HRVs or whatever last? And then they'll give them a number. But that's based on regular scheduled maintenance. If you ignore it and don't regularly schedule maintenance with it, it ain't going to last that long. It's going to start to have problems. And then a lot of the newer units have a lot of warnings that will shut them off, shut the systems down because it can't operate properly. So then all of a sudden now you need to bring it in. So if you're doing regular scheduled maintenance, you never have to worry about that. And then your unit might actually last a lot longer than they said it was going to last.
Yeah. And then so another thing I want to say that's a little bit off note is filters, right?
Yes.
There are services out there that mail them to you. When they mail them to you, go up there and change it, right?
Yeah.
It's like your reminder. Go up there and change it if you don't want the third party to come in. Sure, I get it, privacy. I'm whatever. But get that system in, get up there, change it, do simple maintenance. There's companies out there doing passive systems for vent clean out, stuff like that. It doesn't hurt to maintain it because it's going to hurt your pocket when you have to replace it.
Yeah, 100%. What else you want to? I guess on the rest of the house, new construction. What are the key factors we have to factor in? I guess just your exhaust for bathrooms, things like
Yeah,
that. Same thing.
exhaust for bathrooms, right? We hit all the major points. Especially if you're dropping in those entertainment boxes with all the holes, make sure that
Yes.
that chase is closed. Um, when you're looking at safety, right? So another thing I like to think about is wires. A lot of new systems are going to remote sensors when you're opening and closing doors to know when things are open. Drop a wire. I mean, yeah, I work with big builders. It costs $25 a window. And the homeowner, for someone to go in there and drill holes, it's going to be $200 a window,
I agree.
right? Just
You're
spend the
there already.
$25 per window.
Yeah, just
It's
get.
open.
Yeah,
I'm
that's
a
it.
big fan of hard because batteries fail. There's no indicator. There's no system that says, "Hey, this battery's low." What's going to happen is the alarm's going to go off because the battery's dead in the middle of the night.
And you know what happens next, right after that?
Yeah, you get a call. Everyone gets a call.
Everyone gets a
Everyone's
call,
mad.
but eventually they'll just give up on it. So then they'll just
Yeah,
disconnect that system, and now you're basically dismantling your house at that point, and then the house is
yeah,
not
yeah,
doing what it's supposed to be doing, right? So why not make
yep,
it the easiest when you can at that point, get it done? There's so much that we can do when it's all new construction, even retro. If we do retro, there's
yeah,
a lot that we can still do as well too. If we've got the shell, you know what I mean? So might as well take that opportunity. It's basically future proofing at that point, which is very,
yeah.
very valuable. I agree with you. Yeah.
Very. Yeah, yeah. And I'm a nerd, so I like a lot of internet.
Hmm.
So it doesn't hurt to drop in speeds. I always tell people, I always want to tell people, when you're looking at homes, we have like a minimum height requirement for our plugs. Yeah, great. That's our minimum. Nothing tells you you can't move them up,
Yeah.
right? So if
Oh.
you're working with an older couple that are closer to the edge of retirement and they have problems bending over, raise plugs up. It costs nothing,
And lower
right?
switches down, right?
Yeah,
So you're doing both of
like
them. I know we all are going to get old. We all are going to
yeah,
get old. So you plan for it. Totally plan for it.
yep,
Yeah, I agree
yeah.
with you. I wanted to. So Neil, I actually wanted to talk a little bit about the products that LP is coming out with, because obviously I want people to go and check out that building science section of the company and what you guys are offering. And do you want to just, I know, mention some of the products that are applicable in certain parts of the construction
Yeah,
phase?
sure. Yeah. So I mean, we have a gambit of materials, right? So from the exterior siding, right? Let's talk about water on the outside. Your facade, while is very pretty, if you don't make sure that it operates in which it needs to, it's going to ruin the wall that you designed, the wall that you want, right? So for new construction, you want to make sure that facade is good, well installed, and it prevents bulk water from hitting the WRB. The WRB is there as a belt, right? It's all right. Your facade, water got past it. Cool. Here's a belt. That facade, that WRB also is going to work with condensation. So if condensation on the surface, it can escape out, stuff like that. For time, some time benefit. We have a WRB system, an integrated WRB system. It's called Weather Logic. We have a wonderful tape. Uh, we just launched a new sealant product, so it's a liquid applied. So if you're a fan of liquid, which personally I am always going to be a fan of liquid over tape.
You rolling it or
Um,
brushing it or both? You can do
uh,
either.
it's a cock, so you would cock it
Oh,
and then
okay.
kind of squeegee it out.
Got it. All right.
Seams, fenestration, penetrations, all those things. Uh, that's it's a great product. And if you don't want that, or if you're looking for something with continuous insulation and structure, we have our Nova Core product, which is a 7/16 OSB panel with no WRB, so you still have to house wrap it with 1 inch of foam. We are working on coming out with different thicknesses of foams uh, to help with different areas, right? So I know, like in the north, you need like about 1.5 inches to really do well.
That's what I
In
was going to
in
ask you,
this,
Neil. Is that I know that? Sorry to interrupt. And I'm a fan of that house wrap as well. It's just like a continuous, and there's a lot of guys here in Ontario. They'll offer that service. They'll just come in and do the house wrap. So that's their trade. That's what they
yeah,
like doing. So they know how to do it properly. The key things to remember when you're connecting a house wrap to your actual sill plate, going from a basement foundation to an actual wall on the main floor, and then also on your second floor going to a roof structure. What are the key things that you should remember, and how to install those points, those starting and ending points?
yeah, that's a great question. So I guess depending on your right. So let's say it's our Smart Side product, LPS Smart Side. We have boards, we have all kinds of products all kinds of colors. So when we're doing that, and you have a rain screen, I'm a fan of rain screen. No ifs, ands, or buts. I don't care. You do it because what happens is if bulk water gets back there, it's an extra. It's your
Yes.
suspenders to prevent your WRB from getting wet.
Yes.
So it allows drying. The fact that you're allowing air flow on purpose through there it decreases moisture condensation. It increases the ability to dry if it gets wet. I mean, there's
Benefits.
no
Yeah.
there's nothing negative besides the initial cost because there's no maintenance except making sure that the no bugs get inside if you put a proper bug screen,
Yeah.
top and bottom. So you ventilate and then you incorporate that the soffit up there. I'm a big fan of not allowing Manusso's codes is not allowing that the rain screen air going up into the attic. You have to exhaust it out, so you have to defend a barrier or install a purpose barrier. And then I'm a big fan of unvented attics. I like them. To me, they work great. I currently live in an unvented attic house, so I have no issues. But my preference is vented. So, like in the south, you can have Tech Shield on there to help with radiant barrier. In the north, we don't have a product because moisture and condensation.
Yep.
And then I would ventilate out. I'm a big fan of continuous soffit too. So I'm a big fan of continuous ventilation. Even if it's a brick facade, you can vent each weep hole at the bottom and vent each weep hole at the top. That way, it still allows for air.
Yep.
And what's nice is you don't need a rain screen because that brick space is going to allow for that as long as you don't fill it up with mortar, right?
Yeah. Yeah.
So then ventilating above with continuous soffit and continuous ridge vent or whirlybird, depending on where you are. I like moving air because moving air means comfort. Stagnant air is deadly. And what I mean by that is if you have air, unvented attic or in a room, you get uncomfortable. Moisture increases,
Yep.
right?
Yep.
Temperatures increase. If you don't get moving air, you start becoming uncomfortable. So
Okay.
in energy efficient houses, put fans in rooms. It'll help reduce callbacks.
I agree. I totally agree. So sorry, I took you off there for a second. Then the other
No
products that you guys have, the LPs that are developing.
So we're working on a gasket for air sealing. We're increasing our product portfolio to help incorporate more buildings, right? We want to as a business be more of a solution, right? We changed our names from building products to building solutions on purpose, right? Because we want to provide a good engineered wood to people. So we have 2 tiers of flooring. We have the legacy product. We have a TN350. The legacy is it's a premium quality. We were in the I-joists. We recently sold that, so we're no longer in that. So
Oh, really?
structure,
Okay, I didn't know that. Oh, okay.
yeah,
All right.
yeah. We actually had OSB studs, which were amazing. The straightest studs you've ever seen in your life. Super strong.
Comparable
we built,
to LSLs, like it's basically still engineered studs, right?
Yeah, it's just engineered studs. Yeah, we sold that. So if the higher ups from LP see that, I'm sorry.
Okay. And then subfloor
yeah.
that you got, the subfloor that you're describing, that's a subfloor. That's a 3/4 or 5/8, or it comes in both.
That comes all the way to like 1.25 inches. So depending on.
Oh wow. Okay.
Yeah, I think it's 1.25 inches. So don't get mad at me because
No, you're building science. I get it.
The,
So yeah, we're talking about other products here. No, I wanted the listeners to get an idea of what's out there and what's going on.
Yeah,
so they can take
depending on your need, and then we have commodity OSB. We have Tech Shield for the south. The nice thing about our Weather Logic is the same walls you can put on the sheathing on the exterior. You can put on your roof. It's one system, so it's the same color. We have different thicknesses for that also.
Nice, cool.
Yeah.
All right, Neil, this has been great. We got a couple of segments. I got to talk a little bit about Green Book. It's always nice to remind everybody about construction hazards, and we know that we all work on scaffolds. So basically, you just have to be cautious of that. If falling debris, we're all still used to just leaving everything on our scaffold platforms. Falls, the main cause of critical injuries, and that's in Ontario. We have to have guardrails on those scaffolds. We have to have fall protection systems. Ladders, we have to have proper ladders. We always have to be checking the ladders. We have to make sure that there's no cracks, there's no bends, there's no nothing, and definitely no wood ladders. We're way beyond that time. And then occupation. I don't know why I have always a hard time saying that word. I don't care. Health hazards. Before 2016, exposure limits did not apply to construction projects. Ensure workers, supervisors, and employers are all aware and updated. So we got to basically do that on a daily basis. And then lack of PPE. I know that most tradespeople, most of the time they're wearing their lids. All the time they're wearing safety boots unless they're painters. I don't know why, but painters just refuse to put on. They're wearing Crocs all the time, right? But I mean, they're not doing that. And then I'm not a fan of track pants. It's just like simple, basic things on drawstrings and hoodies and drawstrings. It's just dangerous. It's just you're adding more and more. So, but also I think a lot more of the younger trades are slowly understanding eye protection. Just put it on at the start of the day, walk around and have eye protection. And that's just key. That's paramount because you never know what might potentially happen, right? So that's a little bit of Green Book there. I think we've covered quite a bit, Neil, and I really appreciate I've always had a blast talking to building science guys and girls because you guys are always literally thinking outside the box. You're literally trying to figure out how to make, and ideally, I know you guys would always want a cube for a home, because that's the best way to do it. But I have yet to meet a client that wants to build a cube for a home. They always have protrusions. They always have shifts. They always, yeah.
No. So I come from a construction family. I've been in construction since 12.
Yeah.
My bachelor's degree is architectural engineering. So I had to take a pretty building and make it work. So I'm used to it. You can have whatever you want.
Whatever shape.
Just do it right.
Yeah, that's all it is.
Do it right. That's all I care about at the end of the day.
Okay, so great. So it's www.lpcorp.com, Neil.Freidberg at lpcorp.com. On Instagram, it's LP_pros, and it's LP Building Solutions. So now, sorry, you going to say something?
Yeah, my name is FREI.
Oh, sorry. EI. Sorry. Sorry. EI. LP Building Solutions. If we go there, we have a lot of information that we can actually see and answer it.
Yeah.
Okay.
Yeah, our products are there. We have FAQ sections. A lot of the new videos on product installation, you're going to see my ugly mug because I speak Spanish, so I do the English, and then immedially after I record
we could have did this whole show in Spanish. I don't speak Spanish.
Oh, okay. I was going to jump in on it, man. I'd be convinced.
Well, what do you want to tell the listeners in Spanish? Because we do have a lot of people. I have a lot of listeners down south, honestly, and not just down south, but also in the southern countries as well. And I'm always asking them to come on the show, and they're just so nervous because they don't want to come on because they don't have full English, right? And I'm like, we can make it work. We could totally make it work. So is there anything in particular you want to just share out to the Spanish listeners? Building science-wise.
Building science-wise? I mean, I'm nothing that I can't say in English, but
no, say it in Spanish so they can know.
Para los que usan o ayudan a manufacturar casas, toma el tiempo para hacerlo correcto. What I said was, for those who help build or work on buildings or manufacturing, do it correctly.
Do it correctly. I got temperature and correctly, or do it correctly, right? That's basically as far as I got.
That's the correcto. Do it correctly, yeah.
Neil, this has been a blast. We have the 12 questions to ask you. I'm curious on the answers there. You ready for this?
Yeah.
Awesome. What is your favorite construction word?
My favorite construction word is poly. And the reason why is because depending on where you go, it means different things. Poly in the north is like a plastic liner. Poly in the south is canned foam. So it's
very true.
I use it differently everywhere. It's like a dialect.
What is your least favorite construction word?
My least favorite construction word, it's mainly a series of words, or it's too hard. Or I don't build like that. Those drive me nuts.
I know, eh? It's like they just wanted to stop right there, the conversation. And I'm like, no.
That's not how I built. Yeah.
We're just starting the conversation, so have a seat.
Yeah.
What turns you on in construction, Neil?
Ooh. I mean, everything. Seeing a well-built building. I'm not even talking about the prettiness on the inside, right? Because that you can always change that later. Looking at like good framing, looking at proper air sealing, looking at the care that people actually take into their field, amazing.
I agree. I totally agree. What turns you off in construction?
The opposite. The ones who don't care about it, right? The ones who complain about, I installed it, but I had to come back and fix it on your own dime. You know what I mean? Like
Yeah.
that.
What is your favorite curse word? We haven't been cursing, so I don't know if you want to share
You don't
that.
know. I don't mind. So my favorite is a short for a la madre. So you say a la, which is Spanish for to the mother, basically. Like, oh, it can mean from wow, or it can mean like, oh, go screw
A
yourself.
la madre.
Allah, yeah. So
Okay.
we say Allah for
Uh,
short.
what is your favorite vehicle in the entire world?
My favorite vehicle, honestly, anything that can do off landing. I think going out in the middle of nowhere with no electricity and camping is fun.
Nice. What is your least favorite vehicle?
Uh, there's this is going to be a contentious item, but lifted trucks that remove the EPA requirement items because they want the smoke, they want to roll coal.
The,
Don't
the
do that.
noise and the pollution and everything.
I can get past the noise. It's
Okay.
much more about the pollution.
Got it. What construction sound or noise do you love?
uh, it's funny. It's that the sound of that 22, that ram where you have to hit the nail into
Oh, I know what you're
the
talking about. The
masonry.
ram set. A ram set.
Ram set,
Yeah.
yeah.
It's
But it's
basically a
that
pistol. Yeah, it's a pistol at
yeah.
that point.
It's a 22. Right? It's a
Yeah.
22. Yeah.
What construction sound or noise do you hate?
Someone getting hurt. Period.
Yeah. Yeah. No, I agree. What profession other than your own would you like to attempt one day?
God, my wife always tells me that I should become a doctor because I somehow can Google faster and diagnose myself better than a doctor can sometimes. But regardless, I think a lawyer would be a good position.
What profession would you not like to do?
Man, I wouldn't want to be a politician.
Oh,
Like,
no, not at all. And the last question, if heaven exists, what would you like to hear God say when you arrive at those pearly gates?
what the fuck are you doing here?
Surprised. Surprised. Neil, thank you very much for being on the show. I really appreciate you sharing so much valuable information. I do love the younger generation and the younger trades embracing, wanting to build new and better and actually having the dialogue about building science and understanding building science a little bit more. And if not afraid to ask questions, to other
Yeah, yeah.
people and learn. And I love seeing trades sharing that information. So this is extremely valuable. Really appreciate your time being on the show, man. So thank you very much for that.
Thank you, Manny.
All right. So everyone, again, one last time, it's www.lpcorp.com. You can reach Neil.Fried or Freidberg at lpcorp.com. And it's on Instagram. It's LP_pros and it's LP Building Solutions. We are out of here, man. Thank you so much. Thank you very much, Angelina.